Okay, so this is the drug Elvitegravir, and it is used in the treatment of HIV-1 infections in adults and children over the age of 12. It was approved by the FDA in 2012, and then in pill form in 2014. It is an HIV-1 integrase strand transferase inhibitor, which is significant because integrase is an enzyme that accompanies the HIV-1 virus and aids in the virus's own DNA replication. Thus, this drug can prevent the virus from integrating its DNA into the host as well as transcription. One other significant fact about the drug importance in clinical trials in humans is it actually does not inhibit the topoisomerase enzymes 1 or 2, which is significant for our own gene transcription. Alright, so when looking at the structure of the drug, you can see it is composed of 3 ring structures, 2 of them of which are phenyl. It has a few carbonyl groups, an ether group, as well as a hydroxyl group. There is a nitrogen present in one of the ring structures, as well as a fluorine and a chlorine atom. Now, we'll just add in the enzyme itself. Okay. So when looking at the interactions between the drug and the enzyme, the most notable part here is the strong interactions between the magnesium atoms and the carbonyl groups on the drug here. And this is significant because the reaction catalyzed by this enzyme is actually magnesium dependent. So since this drug has such a strong reaction or interaction, with the magnesium atoms, it prevents the enzyme from catalyzing its reaction. Some other possible sources of drug enzyme interactions are the hydrophobic interactions between this part of the drug here and maybe the phenyl group of the tyrosine residue. There is a potential for dipole-dipole interactions between the fluorine and the chlorine and the nitrogen, as well as potential pi stacking and hydrophobic interactions between the phenyl group and this histone structure here. Okay. And if we were to substitute in the DNA, you would be able to see how this drug binds exactly where the DNA splits, which will prevent the further synthesis of the viral DNA and make this enzyme ineffective.